Hello everybody, welcome. Let's continue with our OpenGL programming using OpenTK and C#. So as we continue here, I'm actually going to put the source code online now. And the source code can be found on GitHub, and I'm going to put a link in the description below. So here's where we left off. We now have the ability to create custom vertex types with any kind of vertex information and vertex attribute information we want. And now what I'd like to do today is actually start wrapping up the classes that we have, like our IndexBuffer, our VertexBuffer, and our VertexArray, or start wrapping that OpenGL code into our own classes for easy reuse and code simplification. So let's go back into our code and take a look at that. So here we are. Here's our vertices array, and here's our old one that we got rid of because we've created our own custom vertex type. I'm going to get rid of the old code there. And we're in the onload function, and here's where we start creating our VertexBuffer, our IndexBuffer, and our VertexArray. And I'm going to take this code and I'm going to start wrapping it into our own classes. So the first thing I'm going to do is go over to our project. Let's create a new class, and I'm going to call this the VertexBuffer. All right, this is going to be public and sealed, and I actually want this class to be able to dispose of all the OpenGL, or to close out all the OpenGL handles that we create. So we'll make this disposable. And then I just need to bring in the OpenTK graphics and OpenGL namespace. All right, let's go ahead and create the constructor. So this will be a VertexBuffer. I do want to have a finalizer, so we're going to call this a VertexBuffer finalizer, and then we'll have a public dispose method. So then we can clean up OpenGL really nicely here. And just because this is disposable, let's go ahead and put a dispose field in here. Is disposed, or I'm going to call this disposed. First thing in the constructor, we'll just make sure disposed is false. Now the finalizer is going to call the dispose function. If the vertex buffer actually doesn't get disposed by calling the dispose function, the finalizer will take care of that for us. So we'll just make sure everything is cleaned up nicely at the end, just in case we forget to call dispose. And inside dispose, we're just going to check to see if it's already disposed. If it is disposed, we're going to return and not do anything. Otherwise, let's go ahead and set dispose to true because we are disposing it now. And then we're going to tell the finalizer we're going to tell the garbage collector that we want to suppress finalize on this object. Okay, and all we're doing here is saying that if we've already called this method, we don't need to dispose again. And so just tell the finalizer, or we're going to tell the garbage collector that we don't need to call the finalizer anymore because it's already been disposed. Let's go back to our game class and take a look at our vertex buffer. So we need to bring in this information here. So I'm going to grab all of this code right here where we create our vertex buffer. We're going to cut it out from here, and let's go ahead and put it in our constructor for our vertex buffer. And so what we need now is a vertex buffer handle, and we need some vertices. So let's make some fields for that. So we're going to create, and actually we're going to make these fields public and read-only. So this will be the public read-only vertex buffer handle. Let's just go ahead and update these. Since this is public and read-only, I like to start my my fields with a capital. So I'm just going to update these fields so they have capital vertex buffer handle. And then let's go ahead and make sure it gets disposed of correctly here. So inside our dispose function, we're going to tell OpenGL that we want to bind buffer. Okay, and we're just going to make sure nothing is bound to the nothing's bound to the vertex array buffer. Put in 0 there, and then we're going to delete buffer, and then we just pass in the handle here. The cleanup code is all set up. So we need the vertices length, or we need the actual size of this vertex buffer and the data. And we're going to change this a little bit. We're not actually going to send the data in when we create the vertex buffer. We're just going to tell the vertex buffer, or tell OpenGL how big we want the vertex to be. We're going to describe it, but we're not actually going to send the data. So let's send some information into the vertex buffer constructor just to describe what this is going to look like. And so the first thing we're going to do is pass in the vertex info. Okay, and the vertex info is what we created last time. Every time we create a vertex type, we're going to create a vertex info that goes along with that type, and we can pass that in here. So then we can tell the vertex buffer what the vertices look like really quickly and easily. And then we're just going to give it a vertex count. So this would be how many vertices this vertex buffer is going to have. For public fields here, I also want to save the vertex count, and then we're going to save the vertex type. Or this is going to be the vertex info. Let's put some guard statements in here. We're going to check to see what the vertex count is. So if the vertex count is less than 1, so we need to have at least one vertex in there. Let's just throw a new exception that the vertex count is out of range. And, you know, I probably want to specify a minimum and maximum count for the vertices that we allow in our vertex buffer. All right, so let's go ahead and make some minimum and maximum values. So I'm going to make a max vertex count. And I'm not exactly sure. I'm going to kind of pick a random value here. So let's just do 100,000 as our max. And then the minimum is simply going to be, so actually this would be the min vertex count. And that's going to be 1. So we want to have at least one vertex if we're creating a vertex buffer. And then I can just put these values in right here. So if the vertex count is less than the min vertex count. Oh, and I didn't make these static. So back up here, these need to be static read only. So these are going to be static for all vertex buffers. This is the min and max vertex count that we allow. Okay, so we're going to check to see if it's less than the min vertex count or if the vertex count is greater than the max vertex count. Okay, then we'll just throw argument out of range exception, and I think we're good right there. Okay, so let's go ahead and now save the vertex info, and then we're going to save the vertex count. All right, so now we're actually going to create the vertex buffer, and so we've done that already. We've generated a buffer, we've bound the buffer, and now we're going to describe the buffer right here, and that's what we're doing. So this buffer data, we're going to describe the buffer, but we're not actually going to send the data in. And so this next field right here, the second field in here, it wants to know the size, and this is the size in bytes. So all we have to do is give it the vertex count. We actually need to multiply that by the size of the vertex, and we get that from the vertex info. So I can type in the vertex info, and we can get the size in bytes right there. And then finally, the last thing we were doing before was we were actually passing in the vertex data right here called vertices. And we're not going to pass anything in right now, so we're just going to pass an in pointer that is 0. And that'll be all done. Now, the buffer usage hint is still static draw. I want to change that. We're going to make this a stream draw. So right now, we could make everything a stream draw, or we could actually specify that in the constructor. So let's go ahead and, you know what, let's go ahead and specify that in the constructor. So we're going to make one more field here, and I'm going to call this isStatic. All right, and let's go ahead and save that as well. We're going to make a read-only field for that. So isStatic, we'll save that right here. Okay, now the buffer usage hint, let's go ahead and set that up. So we'll make a buffer usage hint, and by default, we're going to make this static. So let's go ahead and make this a static draw. And static, what static means is that we're giving OpenGL a hint saying that this buffer is not going to be accessed very often, if at all. Basically, the information we're passing in is just going to remain locked in like it is for the life of the program. Now, we could change the data. It doesn't mean we can't change the data. We're just giving OpenGL a hint saying we're probably not going to change the data, or we're not going to change it very often. We're going to check to see if it's not static. So let's go ahead and check for if it's not static. We're going to make this a hint for a stream draw. So we'll call this stream draw instead. And then over here, we can just pass that hint in just like this. Okay, and so now we can have either a static draw or a stream draw. And stream draw is good for things that we need to update a lot. So if we're going to be updating it every frame, we're going to give OpenGL a hint saying, hey, we're going to be updating this data a lot, so get ready for that. And actually what I'd like to do is give this isStatic a default value. So let's tell it that by default, it is static. All right, so if we're creating a vertex buffer, by default, it's going to be a static vertex buffer, but we can change this as well if we'd like it to be a dynamic or a streaming vertex buffer. Okay, so that looks really good. I think everything's set up there. The last thing I need to be able to do is we now need to be able to pass information, or we need to have the ability to pass vertex data into this vertex buffer. And so let's create a function that will allow us to pass the data or set the data for the vertex buffer. So I'm just going to call this set data. It's going to take a generic type and a generic type array. And I'm just going to call this data, and then we're going to tell it the amount of data or the count of the data that we want to set. Let's go ahead and do some quick guard statements. So the first thing I want to do, I want to check to make sure that the data we're passing in actually matches the vertices that we're using. So we have our vertex information here. So I want to make sure the vertex information that we have matches the generic type that we're passing in as type T here. So let's go ahead and let's get the type of T, and we're going to compare that to the type of the vertex info. So let's get the vertex info, and we're going to get the type, and we're going to compare those. All right. So from our last video, what we did with our vertex info, we actually recorded the type. And that way we can easily compare the type that we're passing in with this function to the type of the vertex info that we sent in the constructor right here. And if they're not the same, let's just throw an exception. I'm going to make this an argument exception. I'll just go ahead and specify this here real quick. Okay, so let's check to make sure the data is not null. Let's make sure the data has, let's make sure the data actually has something in it. Okay, then we're going to check the count here as well. So let's make sure the count actually has some data in it as well. So the count is going to be the number of vertices from this array that we want to send to the vertex buffer. And so we just need to make sure that the count actually is a valid number. All right, so if any of those are true, that means we are, there's either too little count or too much count. And let's just throw a new argument out of range exception. Okay, and so if we've gotten to this point, hopefully our data is all correct. Let's talk about how we now send data to the vertex buffer. The first thing we need to do is bind the vertex buffer. This is a array buffer, and we're just going to give it the handle. All right, so there's a function in OpenGL that will allow us to send information to a buffer whenever we would like to, and that's called buffer subdata. We need to tell it that this is an array buffer. The offset is going to be 0, so we're going to give it an endpoint or an int pointer at 0. Since right now we don't need to modify data in the middle of a buffer, we're just going to make this 0. So every time we're sending data to the vertex buffer, it's always going to start right at the beginning of the buffer and then modify the data from there. The size, now this is the size in bytes of the data we're going to send. So that'll just be the count times the size of each vertex. So we can just get the size of the vertex now by getting the vertex info and then get the size in bytes. And then finally it wants the actual data itself, so I can just type in data right here and that should take care of that. Oh, and it doesn't like that type T, so it should be a non-nullable type. And so what we need to do is we need to make sure that the data we're passing in is actually non-nullable, or that it's a value type. Okay, so type T should always be a value type. That's why it doesn't like this, and it's telling me that type T must be a non-nullable value type in order to use it as a parameter. So all we have to do is tell the function here that type T is always going to be a struct, and what that means is that we're saying that type T is required to be a value type, and that clears up that. And then finally we're just going to tell OpenGL to bind 0 to the buffer, so because we're all done. All right, so array buffer, and we're going to bind 0. That's how you set data now to a vertex array. And that's everything we need for our vertex buffer. Let's go back to our game class, and let's just get rid of all of our vertex buffer code. So here's our vertex buffer handle. Now, instead of having a vertex buffer handle, we're going to have an actual vertex buffer. And this is the vertex buffer we just created. So now we have a vertex buffer instead of a vertex buffer handle. In the onload function, let's go ahead and create our new vertex buffer. Okay, and these are going to be vertex position color. So I can call vertex position color and get the vertex info from that, since we created it beforehand last time. The vertex count is going to be the number of vertices in our array up here. So that'll be vertices, and we'll just give it the length. So is static. Let's go ahead and just leave that as true. And then let's pass the actual data to the vertex buffer. So I'm going to tell the vertex buffer that we want to set data. And let's go ahead and pass in the vertices. And so from here, we just have to give it the count, and it'll just be the length of the vertices array. And that should take care of that. Okay, so now we have a vertex buffer. We've sent the data. Let's go ahead and go down to the, so the vertex array handle now wants the, it's not able to get the handle to the vertex buffer, so we need to tell that where to find that. So it's just going to be our vertex buffer. We're going to give it the handle. Because we actually made the handle a public field that's read-only, we can pass it in just like that. It also needs the size in bytes, so I'm going to go up here, and let's go ahead and get the size in bytes and record it to a local field here. So this is going to be vertex size in bytes. So from the vertex buffer, I'm going to get the vertex info, and we're going to get the size in bytes. And then right here, that'll give us the, okay, so now we're passing in the vertex size in bytes right here, just like that. So nothing's really changed here. We're just using our vertex buffer that we created instead of the vertex buffer handle to take care of all this information. So now I'm going to scroll down here. Let's go ahead and take care of our cleanup code. So here's where we got rid of our vertex buffer. So instead of doing this, all we have to do is now call the dispose function on the vertex buffer. All right, and I'm just doing a quick null check there before I dispose of it. And then finally down here, oh, actually that should be everything we need. I think that's everything we need to do now. So if I run this, I think we should be where we left off last time or just in the same place. Okay, yep, so nothing's changed as far as what we can see, but in the code, we now have a vertex buffer type that we can create for as many vertex buffers as we want very easily. Next thing I want to do is the same exact thing, but for the index buffer. All right, so let's go ahead and create a new class for the index buffer. And the index buffer is actually going to be even more simple. All right, let's bring in the namespace for OpenTK and OpenGL. There we go. The index buffer is just going to have integers as its base type. So all we have to do is pass in the index count for the number of indices we want. Let me go ahead and create some of these fields here. Okay, we need our index buffer handle. This is going to be read-only. And let's go ahead and save the index count as well. Let's put some guard checks around the index count. And before I do that, let's make a minimum and maximum for our index count, just like we did with our vertex buffer. And the min index count is going to be 1, and then the maximum. I think, this is going to be 2.5 times, basically 2.5 times the size of our vertex buffer. So I think we specified 100,000, is that right? Yeah, 100,000. Let's just make that 250,000. And again, this is kind of a random number. We'd have to do some testing maybe to see what's the ideal number we want here for our max index count. And we'll just put some guard statements around the index count. So if the index count is less than the min index count, let's bring that in. So now we just need to save the index count. And let's go back to our game class, and I'm just going to copy this index buffer creation code. So here's our index buffer creation. Let's cut that out. We're going to put it into our constructor. The index buffer handle is now capitalized, so let me change those to a capital I. And we want to specify whether this is static or stream. So let's just do an isStatic as well, just like you did with our vertex buffer. And isStatic is going to be true by default. Okay, let's just save that isStatic here. So I'm going to go back to the vertex buffer. Let's just copy that the static hint, just like we did before. Okay, so we're going to check to see if it's static. If the user does want static, then we're going to change that here. In our buffer data, let's just pass in the hint right there. And just like we did before, we're not actually going to pass in the data here because we're going to pass it in later with a separate function. The first thing we want to do is the size. Okay, this is the size in bytes. So we just get the count. So this means the index count times the size of an integer. All of our data is going to be using integers. And then we don't want to pass anything right here as far as the data goes. So we're just describing it. We're not giving it actual data. So we're just going to pass in pointer 0. And we've created our index buffer. Let's go ahead and take care of finalizing and cleaning up any OpenGL code. So I'm going to make a dispose function. Okay, and finally just clean up the OpenGL handle right here. Okay, so we're going to bind 0 to the element array buffer in OpenGL just to make sure nothing's bound, and then we're going to delete the buffer. All right, so that looks good. The final thing we need is actually a set data function, just like we have for our vertex buffer. And the only thing we're going to be able to pass in is an integer array, and I'm going to call that data, and we're going to give it a count. Let's go ahead and pass in some guard statements, just like I did before. Okay, and finally, let's make sure the count actually has valid values. Okay, so now we pretty much are sure that we have good values being passed in. We're going to do the same thing here for setting the data. Let's go ahead and bind the element array, or bind the buffer. Subdata, buffer subdata. Okay, so once again, our target is an element array buffer. The offset, this is going to be 0 again. So we're always going to start at 0. Now, oops, and one last thing up here. Looks like I put too many of those. Okay, so we're always going to start at 0 when we're passing data in. Again, later on we can change that if we want to change data in the middle of our array or our element array. Maybe we can go back and change this code. But right now, let's make it real simple just to pass the information right at 0. Okay, size in bytes. So this will just be the count that we're passing in times the size of an integer. And the actual data will be data, just like that. Okay, and then let's just tell OpenGL that we're done with this buffer. So we're going to bind buffer 0. And so nice and simple, even more simple than the VertexBuffer. Since everything is an integer array, it makes it really nice and simple. Let's go back to our game class, and now we're going to use our IndexBuffer. So instead of the IndexBuffer handle here at the top of our game class, let's make an IndexBuffer. All right, let's scroll down here. So here's where we actually create the our IndexBuffer. All right, so the count is simply going to be the indices length, and this is going to be static. And then we'll just set the data to our index buffer. So just pass in the indices, and the indices length will give us the amount that we want to change. And there we go. Our index buffer should be complete. We can dispose the index buffer now. So here's where we did it last time. So in the unload function, let's go ahead and dispose of the index buffer. And then inside of our draw code, we need to give it the, so we're actually binding the element buffer here, or the index buffer. We need to give it the handle. So that'll just be our index buffer, and then we'll tell it to handle just like that. And then once again, let's run this, and we should be exactly where we were before. Okay, perfect. So we are exactly where we left off. But the last thing I want to do before we actually start changing what we can see on the display is I want to wrap our vertex array. So let's see, I'm back in... Okay, here we're back in our onload function. We create our vertex buffer, we create our index buffer, and now I want to take this vertex array, I want to wrap this up in our own custom vertex array class. So let's just add a new class. This is going to be a vertex array. Again, public sealed, and we want to implement disposable. Okay, so first of all, we're going to make sure that we can check to see if this is disposed. Here's our constructor. We're going to set disposed to false. We'll set disposed to true if we get to this point, and then let's suppress the finalizer. And let's go ahead and actually set up a finalizer as well to make sure it gets cleaned up if we forget to clean it up ourselves. Let's see, let's go back to our game class and start copying over the information we need for our vertex array. Let's see, we're in the onload. All of this information here, we need to bring into our constructor. So let's just go ahead and cut this out of here. And let's bring it to our vertex array constructor. The vertex buffer is going to be very important to our vertex array. So when we create a vertex array, let's tell it the vertex buffer we're actually using. And I'm going to save a reference to that vertex buffer, and we can make this a read-only vertex buffer reference, and I'll just call that vertex buffer. Let's put a guard statement right here. So we'll just do a new argument null exception. Let's save the reference to the vertex buffer. And okay, so vertex buffer, the reference to our vertex buffer is actually capitalized. So I'm going to change these V's to capital vertex buffer. And okay, we need the actual vertex array handle. So let's go ahead and create one of those up here. Let's make a field for that. It's going to be a read-only integer. Okay, just like we did in our game class. So we're going to have the vertex array handle. That's going to be an integer. And we need to capitalize these V's here since I'm making these public and read only. Let's just make these capital vertex array handle. So now the last thing we need to do is actually set up the vertex attributes. And the vertex attributes can be set up with a for loop now, because we can just loop through the vertex info or get the list of vertex attributes from the vertex info and just loop through them and set it all up right here. I think the first thing I want to do is actually get a local reference to our vertex attribute list or the vertex attribute array. From the vertex buffer, we're going to get the vertex info, and let's get the vertex attributes. Now we just have a reference to all of the attributes. We're going to loop through all of the attributes, and we're going to set up the vertex attributes with the vertex array. So let's loop through all the attributes, and then we're just going to do this stuff right here. So let's move this vertex attribute pointer up into our for loop. We're going to give it the attribute index, the attribute component count, and then the attribute offset. And the vertex size in bytes, we're already getting that information back here, so it's passing it in just fine right there. And then the only thing I have to do next is enable the actual vertex attribute, or enable vertex attrib array. So we're going to move this one up there as well. And then all we have to do is give it the attribute index right here. And then that should be all we need for that. In fact, I can get rid of all of this code now. And then we're binding vertex array 0. I'm going to move this. So when we get the reference to the array, I'm going to move that up here to the top. That should simplify our vertex array creation quite a bit, because all we have to do now is create a new vertex array and pass in the vertex buffer that we're using, and it'll automatically populate all of the vertex attribute information. Okay, so we need to actually set up the dispose here. So we're going to tell OpenGL to bind a vertex array 0 to make sure nothing's bound. Perfect. All right, so that looks like it's all done. Let's go back to our game class. Up at the very top here, we have our vertex array handle. I'm going to get rid of that, and we're just going to have an actual vertex array object. And we're going to move that up here next to our vertex buffer and index buffer. Okay, and now down here, so right after we create our index buffer, let's create our vertex array. Then all we have to do is give it the reference to our vertex buffer. And that should be all done. In fact, that cleans up the code quite a bit and makes it real easy to create vertex arrays. So you can see the code that we have to do now is way more simple, and we can reuse it a ton for whatever we need to do. So let's go down to our dispose function now, or the on unload. There's our vertex array deletion code. We're going to now actually dispose of the vertex array itself, or the vertex array object. Okay, and you can see this code's getting a lot more simple as well. And then inside of our draw code, we're binding the vertex array. We need to give it the handle to the vertex array object that we created. So there's our vertex array, and we're going to get the handle from that. And I think we should be back to where we were before. That's pretty much all I wanted to do. I wanted to simplify our code and make our code ready to make things that are more complicated. So what I'd like to do now is use this vertex, this new vertex buffer, this index buffer, and this vertex array to now generate a bunch of random boxes on the screen. Okay, so we have one box sitting kind of in the top middle of the screen. Let's make a bunch of random boxes that we can just throw out on the screen wherever we want. And so in order to do that, I'm going to make a new random object. All right, and let's decide how many boxes we want to display. So I'm going to make a box count variable, and we're just going to start with 10. And then we can change this to whatever we want when we're done here, but we'll start with 10. Our vertex array creation and our index array creation, we're going to make that based on our box count. Let's create our vertex array again. So this is going to be vertex position color. I'm going to call this vertices, just like we did down here. I'm going to delete this one here eventually. But this is going to be a new array of vertex position color. And it's going to be the box count, but it's going to be the box count times 4, because every box is going to have 4 vertices. So every time we want to put a new box out there, we have to have 4 new vertices. And let's make a for loop where we can update all this vertex information. So we're just going to loop by the number of boxes that we have. So let's just make some random boxes here. I'm going to get some random values for what the width is going to be. So I'm going to make the minimum width 32 and the maximum width 128. And same thing for the height. Now the X and the Y, so the minimum value for the X is going to be 0. So let's put 0 in there. And the max is going to be the window size minus whatever the width is. So I don't want it to go off the display. So we'll pick a random value that's at the right side of the screen, but subtracted by the width of the actual box so it doesn't go off. And so let's go ahead and get the window width. I'm going to save those values, or what the window width is. Since we are inheriting our game class from a game window, we can get that information by getting the client size, and the X will give us the width, and then the same thing for the Y will give us the height. Oh, and this is going to be a window width will be equal to that. Okay, so now we have the window width and height saved. I'm going to pass that in here. So the maximum value for the X is going to be the window width, and I'm going to subtract the actual width of the box so that it doesn't go off the side of the screen. And let's do the same thing for height. All right, so now let's go ahead and send the vertex data to our vertex array now that we have a random box created. And I'm just going to copy these 4 lines right here, okay, and we'll just bring it right up into this loop. So every loop we're going to create 4 new vertices, okay, because every time we create a new box, we need 4 new vertices for that box. And we're going to change this. Now what we're going to do is actually set each one of these positions in their array. So I'm going to tell it that vertices at some index is going to be equal to that, okay? I need to actually keep track of the vertex count of where we are in this array. So at the top here, I'm going to go and create a integer, and this is going to give us the vertex count. And eventually I'm going to need one for the index count as well, so we'll just make an index count. Here I'm going to set the vertex count to 0. And every time I add a new vertex, I'm going to increment this vertex count. We're going to start at whatever the vertex count is, and we're going to increment that to the next line, or to the next vertex. And we're just going to keep doing this for every time we add a new vertex. So I'm just going to add this to the beginning of each line here, just like this. Okay. And so what we're doing is we're just looping through the vertex array, and I'm incrementing the count every time we add a new vertex, and then adding the vertex just like that. This is the exact same thing we were doing before. It's just now we're doing it for a bunch of boxes instead of just one box. All right, so I can get rid of this information down here since we're creating random boxes, and get rid of this old vertex array definition. All right, now the index array we need to kind of talk about a little bit. Let's go ahead and do the same thing we did before. We're going to create the new indices. So the indices array is going to be a new index array, and it's going to be the box count. But we need to multiply this by 6. So we need 6 indices total to define the 2 triangles that make up the box. Let's make the index count, just like we did before. The index count is going to be 0. And then we're just going to loop and create the indices for each box. And this is actually the box count. So we're going to loop through each box. Now let's set the indices in the index array. We're going to use the index count. And every time we add a new index, we're going to increment the index count. And we're just going to follow the same pattern we did down here. So the first one's going to be 0. So we're going to do 0, 1, 2, and 0, 2, 3. So let's make 6 of these. Okay, so this is going to go 0, 1, 2, and then 0, 2, and 3. It's not exactly this easy because 0, 1, 2, and 0, 2, 3 works if we only have one box. But the moment we add another box, we can't start at 0 again. Otherwise, it's going to use the indices of that first box, right, or the first vertex that we defined. So what we have to do is actually advance these indices by the vertex count. Okay, so right here, I'm going to tell the vertex count to be 0 again. And let's go ahead and draw what this looks like. So when we have our first box, this is going to be index 0. This is going to be index 1, 2, and 3. So in our index list, we'll just call this indices just like we were. We're going to go 0, 1, 2. That'll be our first triangle. Then we're going to go 0, 2, and 3. That'll give us our second triangle. But what happens when we add another box? So if I add another box, if I tell it to do 0, 1, 2 again, it's going to do this. It's going to draw these vertices over here. And these vertices are actually going to start at 4. Okay, so this one's going to be 4, 5, 6, and 7. And so what we need to do now is, instead of doing 0, 1, 2, 0, 2, 3, we need to now go 4, 5, 6, and then 4, 6, 7. So here's our first one, and our second one will be 4, 6, and 7. So here's our 2 boxes. There's box number 1, and here's box number 2. So we need to advance the indices so they get to the next box. And the way we do that is by advancing by the actual vertex count. So you can see this box has 4 vertices. And so what we're going to do is when we get to the next box, we're going to start at the current vertex count, which is 4. So this one's going to start at 0. This one's going to start at 4. And if we had another box, it would start at 8. And so let's go back to our code and let's advance the indices by the actual vertex count. So the vertex count here is going to start at 0. So we're just going to increment these by the vertex count. And then every time we loop and add a new box, I need to increment the vertex count by 4. All right, and so now we have our vertex count is up to date. Our index count is up to date. I can get rid of the old indices array. And I think we might be good to go. Let's go ahead. I'm going to change actually the background color. I'm going to make this a lighter color. So let's change the clear color, and I'm just going to make this kind of a light gray. All right, and so let's take a look at this here. So we're creating some random vertices for the boxes. We create the indices. We send that data to the vertex buffer, the index buffer, the vertex array is created. And the only thing we need to change now, okay, so if we go down to our draw code, when we draw elements, what we're doing here, this second argument wants the count or the number of indices we're going to draw. And that's not going to be 6 anymore. If I do 6, it's only going to draw one box because each box has 6 indices. So 1, 2, 3, 4, 5, 6. So we actually need to tell it the number of indices for every box that we have. And that's why I saved at the very top, I saved this index count. And we can just go down here and pass in the index count. And that should draw every box. And it looks like we might have one more error if I scroll up here. Oh, I need to make that specify a floating point value there. Let's go ahead and run that and see what happens. All right, there we go. Okay, so we're drawing random boxes at random sizes on our game window. All right, and that looks really good. And we can change this so these boxes actually have random colors as well. Right now, they're all just the same color. So you can kind of see how this would work with texturing as well. So instead of specifying a color, we can actually specify a texture position for each one of these vertices, and then we're going to end up with pictures in each one of these boxes. And so instead of just having a box with a color on it, we can have a box with a picture in it or a texture. Let's go back to the code and let's actually just make some random colors now. So instead of having the same color for every item, let's make some random floating points for red, green, and blue. So each box is going to have a random color. And we just need red, green, and blue. Okay, and over here inside of our color code, we're going to pass in the red, green, and blue value that are random colors. And I'm just going to copy this and paste it in for each one of them since we're just going to make every box the same random color. And let's run that. And they should just be random colored boxes now. There we go. That looks good. Let's run that again. Perfect. Okay. That looks good. And we can up this as well. Let's go ahead and change the number of boxes. So instead of 10, let's make 100 and see what that looks like. And let's make it 1,000. So we've wrapped our VertexBuffer, our IndexBuffer, and our VertexArray into these classes that are easy to use and reusable, and it simplified our code a lot. I would like to do the same thing with our Vertex and pixel shader code. And from there, moving on to being able to texture these boxes with something and draw images to the screen.